chloroligand comes first due to alphabetical order, ignoring the bis. But what about the oxidation state of the central metal? That determines the suffix.
Good morning, students. Today we are discussing about IUPAC nomenclature of complex compounds. So now coming to the examples, some examples are given. So for these examples, how to write the IUPAC nomenclature we are discussing. So now first compound, this is the platinum, NH3 twice, Cl, NH2, CH3 and Cl is there. So totally this one. Actually this one is dissociates like two ions, that is one is the positive, means that is the cation, and this is the anion. So how it is dissociated means this total part is a positive part and this is the negative part. Why? Because this is the complex part, so this complex pair is not dissociates completely. So total which is in the square bracket, that is totally one of the ion and outside is the another ion. So now when we are writing IUPAC nomenclature, we have to start with the cationic part only. Cationic part. For example, here, what is the cationic part means here K plus 1. Here, this charge you have to give it here, and this one you have to give it here. Then this is the -3 charge will come. So K plus 2 and this complex pair contain -3 charge. So then here complex having negative charge, here complex having positive charge. And here also this is the here 1 is there, so this is the K plus 1 and 4 minus 4 charge is there. So like that. So one of the complex compound, is a cation. In this complex compound, complex pair is act as a anion. So now if it is a complex or complex is a cation or anion, we have to start with the cation only. Here, what is the cation? Complex pair is a cation and Cl is a anion. Here, K is a cation. Complex here, it is a anionic part. So now in this also cationic part only we have to start. Here also cationic part only we have to start. So now cationic part. So in this cationic part, which one? That is the complex sphere is a cationic part. So when we are writing the complex sphere, first we have to start with the positive charge and after that negative only. So in the positive charge means cationic part, that cationic part is a complex sphere. So then we have to start this one. In this we have to start. Now platinum is a metal and ammonia is a ligand and Cl is also ligand. This is also methenamine is also ligand. So when we are writing complex pair, we have to start with ligands. So here three types of ligands is there. This is the amine. This is ammonia ligand name is the amine, and this is the Cl, that is the chloro, and this is the methenamine. So these are the ligands. So first in the cationic part means if it is a complex pair, on that first we have to write the ligands and after that only metal we have to write. So here three types of ligands are there. So three types of ligands are there. We have to start, we have to take it as like alphabetical order only we have to start. So here this is the amine. So this amine alphabetical order, first letter, that is the A, and this is the chloro, so C, and this is the methenamine, so M, methenamine this is. So now this is A, first letter will come, so that's why this is the amine we have to write. So this amine how many times is there? 2 times is there. So that's why we have to write diamine. Next after the amine, chloro we have to write. So chloro, and after that ligand only first of all have to write, after that only metal. So ligands, different ligands are there, we have to go with the alphabetical order. So now first amine is completed and after that chloro is completed. Now methenamine. So diamine, chloro, methenamine. So ligands are completed. Now coming to the metal. So that is the, what is that metal? That is the platinum. Actually here we have to remember metal is in the cationic part, that name directly we have to write. If metal is in the anionic part, that means complex pair is a anionic part, that metal we should suffix, means for the metal we have to add suffix 8 also we have to add. But here no need. Why? Because this metal is in the cationic part, so no need directly metal name only we are writing, that is the platinum. And after that we have to write the oxidation state also we have to write. And after that, so this is totally complex pair completed. After the metal we have to write metal oxidation state we have to write. And after that, this means ionization sphere, totally complex sphere completed. And after that, ionization sphere we have to write. That ionization sphere name, that is the chlorine is there, so that's why that is the chloride. Here we are not writing as a chloro. Why? Because here chlorine is act as a ligand, so that's why we are writing the chloro. Actually this is a negative ligand. Negative ligand suffix we have to add O, so that's why chloro. And this chlorine is not act as a ligand, this is a ionization sphere, so that's why this is Cl minus 1, that is the chloride only. So like that we have to write. So now calculate the oxidation state of platinum. Platinum oxidation state always we have to represent it in the Roman numbers only we have to represent. So now platinum we have to calculate, so put the X. Ammonia charge is 0, so 2 ammonias, 2 into 0 0. Next Cl charge is minus 1, means oxidation state. And methanamine, this is the neutral ligand only, so that's why this is also 0. And Cl is a minus 1, so total equal to total charge is 0. So x equal to this is minus 2, so that's going that side, means that is the 2. So x equal to 2 means platinum oxidation state is 2. So that oxidation state we have to represent it by the Roman numbers after the metal name, So this is the name of this first compound. What is the name of this compound? Diamine chloromethanamine platinum. Why? Because platinum only we have to write. Why? Because platinum is in the cationic part. So cationic part, if complex pair is a cationic part, then metal we have to write that name only we have to write. Don't add the 8 for if it is that metal is in the presence in the cationic part. So platinum. And after that, oxidation state we have to keep that metal oxidation state we have to keep in the brackets by the Roman number only. After that, cationic part is completed, then anionic part, that is the chloride only. So here oxidation state if you calculated, platinum is X and ammonia is the 0. Why? Because that is the neutral ligand, and the chlorine is also, this is the negative ligand, the charge is minus 1. And methanamine is also neutral ligand, so that is 0, and the chlorine charge is minus 1. So totally X minus 2 equal to 0, then X equal to 2. So platinum oxidation state is 2. So this is the name of the first compound. So now coming to the second compound. Here K3, what is that? K3CO means this is the cobalt, and OX3. OX3 means OX is a ligand, that is also negative ligand, that is the oxalato, that is the name of the OX. So now we have to write first which part we have to write, cationic part only we have to write. So in this, which is a cationic part? Here K plus 1 charge, here minus 3 charge. So potassium is a cationic part and complex pair is a anionic part. So first we have to start with cationic part, that is the potassium. Don't write tripotassium, only potassium only we have to write, potassium. So cationic part completed. Now we have to write the anionic part. Anionic part is a complex pair. So when we are writing the complex pair name, then first of all we have to write the ligands. After that only metal we have to write. So ligands, what are the ligands? Oxalato is a ligand. How many times is the oxalato is there? 3 times. So that's why we have to write trioxalato. So ligands are completed. Now cobalt, metal is a cobalt, but that metal is in the anionic part, so that's why we have to write cobaltate. 8 is the suffix when metal is in the negative, means anionic part. Here metal is in the positive part, so that's why directly we are writing the platinum only. But here cobalt is in the negative part, so that's why we have to write cobalt with 8 also. So then cobaltate. Cobalt 8 is a suffix. After that, after the metal we have to write the oxidation state, and after that, so totally completed. So first cationic part and after that anionic part. In the anionic part, first it is a complex pair, so that's why in the complex pair first we have to write the ligands only. After the ligand, metal name we have to write. Here metal we have to write the 8 also. Why? Because this is in the anionic complex pair, so that's why 8 also we have to add. And after that oxidation state also we have to add. So what is the oxidation state? K3. Potassium is the +1 charge, so 3 potassiums are there. So 3 into 1, 3 plus cobalt is the X, and oxalato is the -2 charge. -2 charge. Actually oxalato formula, this is the O minus, C double bond O, C double bond O, O minus. So this is the ligand structure oxalato. So how much charge is there? -2 charge is there. So one oxalato having -2 and three oxalato having totally 3 into -2, then that is the -6, equal to what is the charge? Total charge is 0. Then x minus 3, x, this is the +3 and -6, so -3, x minus 3 equal to 0, then x equal to 3. So what is the oxidation state? That is the 3. So that oxidation state we have to represent it in the Roman numbers only. So this is the name of the potassium trioxalato cobaltate 3. That is the name of that. Now coming to third compound. In this, potassium is a ionization sphere and complex pair is act as a anion. Why? Because this is K +1 charge. Here FeCN6 -4 charge. This is -4. Now complex is act as a anion and this is the ionization sphere. First what we have to start? Positive part only, means cationic part we have to start. So what is the positive part? Potassium is the positive. So write down potassium. Next after that anionic part. So anionic part is a complex pair. Then we have to write in the, when we are writing the complex pair, first we have to start with the ligands. So here what are the ligands? Cyano is a ligand. So how many times is that? 6 times is that. So hexacyano. Next, after the ligands we have to write the metal. So what is the metal? This is the iron. Actually this is in negative part, so that's why we have to write ferrate. 8 also we have to add. So ferrate. After that oxidation state. So what is the oxidation state? 4 potassiums means 1 potassium charges +1, then 4 potassiums 4 plus iron oxidation state X, and Cn is a negative ligand, that charge is -1, Cn minus. So 1 Cn having -1 charge and 6 Cns -6 equal to 0. So total charge is 0 only. Now x equal to x minus 2 equal to 0, then x equal to 2. So this is the oxidation state. This is the 2. So what is the name of this? Potassium hexacyanoferrate 2. That is the name of that. Now coming to this one. Here complex pair is act as a cation and chlorine is a anion. So first cationic part add, write down. This is the complex pair. So first of all write down the ligands. So what are the ligands are there? Here 2 different types of ligands are there. One is the amine and second one is the carbonato. This is the CO3 -2, that is the carbonate. But here when we are writing the ligand, O we have to add. So this is the carbonato. So here 2 different types of ligands are there. So we have to go with the alphabetical order. So here amine first we have to write. Amine how many times is there? 5 times is there. So that's why pentaamine. After that when one more ligand is there, that is the carbonato. After that metal here 8 we have to give or not, you have to check. Why? Because this one it is a positive part. So positive part, don't give the complex pair is a negative part, then only you have to add suffix 8 for the metal, central metal atom. But here this is a positive part, so directly we write down cobalt only. Don't write cobaltate. Why? Because it is a positive part, so cobalt only write down. cobalt. After that metal, we have to write the oxidation state. And after that, which one ionization sphere is the chlorine is there. So that's why chloride. So first calculate the oxidation state of cobalt. Cobalt is a X and ammonia is a neutral ligand, so there is no charge. So five times ammonia is there. Then that is the 5 zeros only. So 0. Next CO3. CO3 is the negative ligand. The charge is a CO3 minus 2. So then it is a minus 2. This is Cl minus 1 equal to 0. So X minus 3 equal to 0. Then X equal to 3. So what is the oxidation state of cobalt? That is the 3. So write down in the Roman numbers. So this is the name of this pentaamine. This is the first ligands only you have to start. So pentaamine cobaltate. What is this? Carbonato cobalt. Cobalt oxidation state is 3 and chloride. So this is the name of this. Next, for this write down. Here complex pair is a cationic part and this is a anionic part. So first we have to write the complex pair. So when we are writing the complex, why? Because it is a cationic part, it is a anionic part. First start with cationic part. Cation is a complex pair. So when we are writing the complex pair, we have to start with ligands only. So what are the ligands here? Water is a ligand. So how many times is there? 6 times is there. So 6 times we have to write hexa. Water is act as a ligand, then we have to write the aqua. So that ligand name is aqua, hexa aqua. So water completed, and after that metal name we have to write. Here iron we have to write. Don't write the ferrite. Why? Because it is a cationic part. It is a cationic part. So iron only write down. Hexa aqua iron. After that oxidation state. After that chlorine is there. So chloride write down. Chloride. Now calculate the oxidation state. Iron is the X. H2 is a neutral ligand. So then there is no charge. So then 6 water molecules also, ligands also 0. And 1 Cl charge is minus 1. Then 3 chlorines is the minus 3 equal to 0. So X equal to 3. So what is the iron oxidation state? That is the plus 3. So this is the name of this. Hexa aqua iron 3 chloride. So this is the name of this. So right like this we have to write. So finally when we are writing the complex compounds, first you have to start with the cationic part and after that only anionic part only we have to start. So when the cationic part is complex, if the complex is a cationic or anionic, in this two parts are there. One is a ligand and another one is a central metal atom. So when we are writing the IUPAC nomenclature, first you have to start with the ligands. After that only metal name you have to write. After that, after the metal, oxidation state of the metal also we have to write. So like this we have to calculate. And one more thing you have to remember, when complex pair is a cationic part, then metal name directly we have to write. If that complex pair is a anion, then with the metal name you have to put the suffix is a 8 also we have to add. So like this write down. Thank you.